What if everything we think we know about physics, from an apple falling from a tree to the wild weirdness of quantum mechanics, is built on a foundation that's, well, a little bit broken? Today, we are going to dive into a pretty radical paper by Lei Thon Hao, brought to us by Chat Truth, that proposes a single unified way of looking at, well, everything. It's called the Postmodern Unified Theory, or UPT for short. Think about it. Right now, we've got all these amazing, brilliant formulas that describe the universe, but they don't really talk to each other. They kind of live in their own separate worlds. So this theory comes along and asks a really bold question. What if they're not separate at all? What if they're all just different ways of singing the same fundamental song? All right, so here's our game plan. First, we're going to look at why anyone is even searching for a unified theory in the first place. Then we'll get into the core idea of UPT, this thing called a found-on. After that, and this is the cool part, we'll see how it claims to build all those famous formulas we know and love. Then we'll ask, okay, how could you actually test this? And finally, we'll zoom out and think about what it all means. So let's set the scene. This hunt for a theory of everything is seriously one of the holy grails of modern science. But what's the actual problem it's trying to solve? I mean, why do we even need one? Here's the thing. Our current physics is unbelievably good, but it's also kind of fractured. We have classical mechanics for everyday stuff, baseballs, planets, things we can see. We've got general relativity for the huge scale of gravity and space-time. And then we have quantum mechanics for the absolutely bizarre world of tiny, tiny particles. It's like having three world-class experts who are geniuses in their own field, but they all speak different languages. And that becomes a huge problem when you want to describe something like a black hole, which is both incredibly massive and incredibly small. So how in the world does UPT propose to get these different languages to talk to each other? Well, it starts by introducing a brand new concept, a whole new way of thinking about the basic stuff that reality is made of. Everybody meet the found-on. This is the absolute heart of the theory. Now get this, it's not a particle like a little marble, and it's not a field that spreads out everywhere like magnetism. The paper calls it a dynamic, self-organizing domain of energy. The best way to picture it is like a little self-contained bubble of reality. The whole point of this idea is to just completely erase that old line we draw between a thing and the space around it. And how do you describe one of these found-ons? With this right here, a single master variable, IXT. Just think of it like the ultimate genetic code for that little pocket of energy. The theory's big claim is that this one function holds every piece of information you'd ever need about it, at any spot x and any time t. It's the universal language that UPT once used to write the entire story of the cosmos. And this is where it gets really simple and kind of beautiful. From that one single variable, UPT builds everything from a single core idea about energy. It says the total energy in any spot is just two things added together. It's basic, fundamental, base state energy, plus a second part that describes how that energy is changing or moving. That's it. That's the engine that drives the whole theory. Okay, now this is where the rubber really meets the road. It's one thing to have a cool new theory, but can it actually reproduce the physics we know is right? Well, UPT says yes, it can. It argues our most famous equations are really just simplified versions of its bigger, more complete picture. Let's start with maybe the most famous equation on the planet, Einstein's mind-blowing connection between mass and energy. How could a new theory like UPT possibly explain something as fundamental as E equals mc squared? I love this because it totally reframes that iconic formula. According to this paper, UPT's main equations give you the total energy of a fountain, all of it, whether it's moving, vibrating, you name it. And E equals mc squared? Well, that's what you get when the fountain is just sitting there, perfectly still. It's the rest energy. It's not the whole movie, it's just one perfect frozen frame. Okay, next up, waves. It's kind of amazing that the same basic math describes the sound coming from a guitar string and the light traveling across billions of light years from a distant galaxy. These wave equations are just fundamental to how we understand the universe. This comparison really nails the whole approach of UPT. Its general equation for a wave naturally includes a little something for damping. That's just a physics term for how real waves lose energy and fade away. Like an echo dying out. The classic wave equation we all learn in school, that's the perfect, idealized textbook version where that fading factor is basically zero. UPT just claims its version is a more honest, real-world description. All right, so this is all a really neat and elegant idea. But for a theory to be actual science, you have to be able to test it, right? You have to be able to prove it wrong. So how would a scientist actually take these ideas off the chalkboard and into a real lab? And what's cool is the paper doesn't just leave it at that. It actually lays out a clear four-step recipe for an experiment. It basically says, look, you can measure how waves behave in a system to figure out the theory's unique parameters, those Greek letters like alpha, beta, and gamma. This is essentially the instruction manual for how to calibrate the UPT model for any system you want, turning it from a philosophy into a real, practical tool. Okay, let's zoom all the way out now and look at the biggest picture. If UPT can really do what it claims, what does that mean for physics, for everything we thought we knew? This table from the source material just perfectly captures the theory's incredible ambition. It's basically positioning UPT as the fundamental operating system for all of reality. So in this view, classical mechanics is what you get when you zoom out so far that you just treat everything like simple lumps. It's a simplified case. Electromagnetism? That's a more straightforward, linear version of UPT's rules. Quantum mechanics isn't some separate weird thing. It's just what happens when you apply quantum rules to the waves that UPT says are already there. And even relativity is just the next logical step, taking UPT's math and extending it into four-dimensional spacetime. So let's wrap this all up. The postmodern unified theory is really making four huge claims at once. First, that it's a unified language, getting rid of that old split between particles and fields. Second, that it's consistent, because it can actually build our most trusted formulas from its own core principles. Third, it's modular, saying all those different branches of physics are just different user interfaces for the same underlying engine. And finally, and this is maybe the most important part, it claims to be testable science, with a clear way to see if it's right or wrong. In the end, a theory this big forces us to ask a really profound question. If UIPT or something like it actually turns out to be right, does that mean we've reached the end of physics? Is that the final chapter? Or does unifying everything we know now just crack open a whole new book, revealing a universe of questions we haven't even dreamed of asking yet?